Om Swastiastu. Hello everyone. My name is Samuel Batubara with student number 22055311097. In this video, I will explain process of Vickers hardness test on piston and boring of Vespa scooter and Yamaha Jupiter Z motorcycle. First, the test material is molded into resin and then smoothed using sandpaper and velvet cloth to produce a smooth and shiny surface. The Vickers hardness test use a diamond indenter shape like a pyramid with an angle of 136 degrees. A certain load is applied to the surface of the material, leaving an indentation. We measure the two diagonals of this indentation, labeled D1 and D2. Then take the average value. The hardness value is calculated using the equation HV equal 1.854 multiplied by the load divided by the square of the average diagonal. This method is widely used because it is suitable for both soft and hard materials, including thin section. In this experiment, the test was performed using a standard Vickers hardness tester. The load applied was 1 kg with a dwell time around 10 seconds for each indentation. We tested 4 components: Vespa piston, Vespa boring, Jupiter Z piston, and Jupiter Z cylinder boring. Each component was tested at 3 different points to obtain a representative average. After testing, the test point results were observed using an inverted metallurgical microscope at 100 times magnification, and images were taken using future window software. The diagonal indentation measurement process was carried out using ImageJ software. First, determine the measurement scale by drawing a line on the scale image and setting the desired scale. In this test, I used a scale of 0.05 mm. Once the scale is set, open the indented image file and draw a line along the diagonal and then click Measure. Calculate the average of the two diagonals at each test point. The Vickers hardness is calculated using the Vickers hardness calculator website. Be sure to use multiple websites for comparison. After that, calculate the average value of the 3 test points to calculate the Vickers hardness. The following is a microscope image and the results of the Vickers hardness measurement of the Vespa motorbike piston. And the following is the microscope image and the results of Vickers hardness measurement from the Vespa motorbike boring. The following is a microscope image and the Vickers hardness results of the Yamaha Jupiter Z motorcycle piston. This following figure is a microscope image and the results of Vickers hardness measurement of the Yamaha Jupiter Z motorcycle boring. The following is a table of Vickers hardness calculation data for Vespa motorcycle pistons and boring. You can see the average value of the hardness Vickers and the standard deviation for each piston and Vespa boring. And following is the table of Vickers hardness calculation data for the piston and boring of the Yamaha Jupiter Z motorbike. For the Vespa component, the piston had an average hardness of 98.44 HP, with a standard deviation of 20.79, indicating a noticeable variability across the test point. Meanwhile, the Vespa boring exhibited a much higher hardness of 205.23, with a low standard deviation for only 8.55, showing a much more uniform material condition. This difference is consistent with the functional requirement of the two components. For the Yamaha Jupiter Z, the piston hardness averaged 99.85, which is very similar to the Vespa piston. The standard deviation was only 5.26, indicating a more uniform surface compared to the Vespa piston. The cylinder, however, had an average hardness of 155.05, which is significantly lower than the Vespa cylinder. It also showed a very large standard deviation of 44.98, suggesting that the cylinder material has high variability or inconsistency. When we compare the piston of both engines, we can see that the hardness values are almost identical, around 98 to 100 HP. This suggests that both manufacturers likely use aluminum-based alloy with similar compositions, which is common for pistons. The hardness level is appropriate because piston must absorb combustion force while maintaining ductility. In contrast, the hardness of the cylinders or the boring shows a clear difference. The Vespa cylinder is significantly harder at 205 HP, while the Jupiter Z cylinder is only around 155 HP. This may indicate the use of harder cast iron material in the Vespa, or simply better material consistency. The large variation in Jupiter Z's boring hardness suggests possible difference in casting quality or microstructure. From a functional perspective, the hardness level makes sense. The piston have relatively low hardness and higher ductility, which help them absorb repeated combustion loads. The cylinder require higher hardness because they experience constant friction, so harder material provides better wear resistance. The Vespa cylinder's higher hardness suggests that it may have a longer service life compared to the Jupiter Z cylinder. In summary, both pistons have similar hardness values, indicating similar material characteristics. The Vespa cylinder is significantly harder and more consistent than the Jupiter Z cylinder. The differences in hardness and standard deviation reflect difference in material composition, manufacturing, and expected performance. Overall, the results align well with the functional demands of each engine component. And that is all of my presentation. Thank you for watching. Om Santi 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 Om.